In the next example, we're going to use clues about what quadrant the angle is going to be in from the given context, and also reference angles to find the missing values. So they want us to find the exact values of the remaining 5 trig functions of the function of theta, and we're given one of these values, and the secant of theta is the square root of 3. So we can go ahead and record that square root of 3. A big thing here is that it's a positive square root of 3. That's going to tell us something about what quadrant it is. Now, secants are related to cosines, and cosines and secants are going to be positive in the same quadrants. Now, let's go back to this acronym, or this idea that we had, that all students take calculus. This should help you remember what trig functions are positive in which quadrants. So when we look at this, every single trig function must be positive in the first quadrant. When we look at this one, sine and cosecant have to be positive in the second quadrant. In the third quadrant, what we know is that anything associated with tangent, so tangent, not so much fangent, but tangent, tangent and cotangent have to be positive in the third quadrant. And the calculus implies that anything associated with a cosine, which is a secant, has to be positive. So, using this one contextual clue, knowing that the secant and cosine are positive, means that we can figure out that we've got to be in one of two quadrants. We either have to be in the first quadrant because everything's positive in the first, and in the fourth quadrant because cosines are positive in the fourth. Now we've got to use one more context clue here to figure out where we are, because it could be in either one of those. We got to get it eliminated down to just one. Well, they're telling us that the tangent is less than 0. That means the tangents have to be negative. We only are going to get a negative tangent in the fourth quadrant because, remember, all trig functions are positive in the first. So, okay, so we use some deductive reasoning to figure out what quadrant we're in. We have an angle that's over here in the fourth quadrant. The other thing that we know is that the secant value is the square root of 3. So let me put that in here. It's a positive square root of 3. But whenever we do a secant of theta, remember the secant is always the r value over the x value, which means clue-wise we know that our hypotenuse is the square root of 3, or the radius of our circle, and we also know that our x value is 1 because it's the square root of 3 over 1. So all right, let's go draw our reference triangle, and then we can figure out some of these others. So let's say that this is our reference triangle. There's our right angle. What we know right now is that the value of r is the square root of 3. That's our radius, square root of 3. The value of x, or our adjacent side, has to have a length of 1. So now we're going to have to use Pythagorean theorem to help us figure out what this opposite side is, or the value of y. So we know that the square root of 3 squared is going to have to equal 1 squared plus the value of y squared, whatever that is. So that is going to be 3 equals 1 plus y squared. That means y squared is equal to 2, which means y is equal to the square root of 2. So now the y value has the value of square root of 2. Now we should be able to answer all the remaining trig questions, but remember, I'd better put this in here so I don't forget as well. This is a negative value since we went downward, so I'm going to clean that up and make sure it's nice and clear. Y is a negative square root of 2. That is this opposite side. Positive square root of 3, positive 1. Okay, so let's clean the rest of these up. If we know the secant, it's pretty easy to find your cosine. All we do is reciprocate that, which is going to be 1 over the square root of 3, which is, if we rationalize, it's going to be the square root of 3 over 3. Now let's go get the sine. The sine, we're going to use a reference angle, is the opposite side, or y, over the adjacent, or the hypotenuse, which is square root of 3, or y over r. So that's going to be negative square root of 2 all over square root of 3. Now we're going to have to rationalize, which means take top and bottom by the square root of 3, which is going to give us a negative square root of 6 all over, and this is square root of 3 times square root of 3, which is 3. So negative square root of 6 over 3, which means now we should be able to find our cosecant fairly easily. All we got to do is reciprocate this, which means, I'll write it over here because it's going to take a little bit of work. It's a negative 3 over the square root of 6, which, okay, if we simplify that, square root of 6 times the square root of 6. This is going to be negative 3 square root of 6 all over 6, and that'll reduce to negative square root of 6 all over 2. Now, there was another way of doing that. Let me show you that quickly. Sometimes it's not the easiest just to reciprocate your answer. We may have wanted to take just this beginning sign one, which was a negative square root of 2 all over the square root of 3, and reciprocate this. So then to get the cosecant, it's going to be the square root of 3 all over square root of 2, negative, and now rationalize, which means we're going to multiply top and bottom by the square root of 2. And you can see you'll get the same answer, but you have some leeway in which way you want to go with that. So square root of 2 times the square root of 2, that's going to be the square root of 6 negative all over 2. Same thing. And that doesn't simplify any further. And then the tangent is going to be the opposite over adjacent, or the y value over the x value. So that's going to be a negative square root of 2 over 1, which is just simply the negative square root of 2. Then if we want to find the cotangent, we want to reciprocate this. So it's going to be a negative 1 over the square root of 2, and then rationalizing is going to be a negative square root of 2 all over 2. So we found the other 6 trig ratios by using the context clues of what quadrant you're going to be in. Let's take a look at another example. The next one says the sine of theta equals 5/7. Now this first clue, I guess I can put this in here, 5/7. The first clue says that sine is positive. Sines are only positive in the first quadrant because all trig functions are positive in the first quadrant. And then the other thing is, students, that means sines are positive in the second quadrant. So now we've got eliminated down to the first and the second quadrant. You only got to be in one of those two. The other thing that's going to help you decide what quadrant you're in is by looking at your second context clue. It says the cotangent is greater than 0, which means it is positive. The only time cotangents are positive is in the first quadrant or the fourth quadrant, but we already know that we got to be in the first or the second by our first context clue that the sines have to be positive. So we are now guaranteed that we're looking at a reference triangle and angle in the first quadrant. And here's what we know about it. Since it was given to us as a sine curve, we know that the opposite side is 5 of the angle, and the hypotenuse is 7. So from there, we can figure out the adjacent side by using the Pythagorean theorem. So 7 squared equals 5 squared plus whatever the x value squared is. So we'll have 49 equals 25 plus x squared. That means x squared has to equal, that better be 24. So that means x is equal to the square root of 24. Okay, so now we're going to have to remember the square root of 24 needs to be simplified, so we're going to work with some radicals here. Are there any perfect squares in 24? And that answer is yes. 24 can be written as the square root of 4 times 6, and the square root of 4 is 2, so it's 2 times the square root of 6 in simplest radical form. There are no more perfect squares in the square root of 6, so I know that I'm done with that. So it's 2 times the square root of 6. Now since we're in the first quadrant, every single one of these values, radius, x and y, are positive. So let's go to the cosecant. That should be the next easiest one to do. We just simply reciprocate, or if we want to, we can get the hypotenuse over the opposite, or r over y. The cosine. The cosine is going to be the adjacent side length, which is 2 times the square root of 6 all over 7. If we're going to get the secant, we're going to have to reciprocate, and it's going to be 7 divided by 2 square root of 6. Then we're going to rationalize. Multiply top and bottom by the square root of 6. This is 7 square root of 6 all over 2 times 6, which is 12. So it's going to be 7 square roots of 6 all over 12. Just to get that 12, see if you had any discussion on that. Square root of 6 times square root of 6 is 6, so 2 times 6 is 12. And then finally the tangent is going to be the opposite over adjacent, or the y value over the x value. So that means I'm going to have a little simplification to do, so I'm going to clear some space and I'll work that. We've got 5 divided by 2 times the square root of 6. Again, we're going to be forced to rationalize square root of 6, square root of 6, and we're going to end up with 5 times the square root of 6 all over, and this is going to be 2 times 12, or 2 times 6 again, which is 12. And then the last part, I would reciprocate this, or I just go and grab as the x value over the y value. So it's 2 square roots of 6 all over 5. So These take the most thought because you got to figure out what quadrant you're in first. Then you're going to have to figure out what sides they're giving you by the context clues, like on the sign. We know the opposite and hypotenuse. On the prior one, we knew that secant, so secant gives you the length of the hypotenuse over the adjacent leg, or if you want r over x. Use those clues along with the second clue here to help you figure out what quadrant you're in. Use Pythagorean theorem, and then you're well on your way to finding all the remaining trig ratios. So that takes a little bit more work and time, but it can be done.